Welcome to this Winemakers Research Exchange virtual sensory session, exploring the chemical and sensory impacts of acid additions in Chardonnay. Today, we are presenting two experiments comparing acid additions with tartaric and malic acids. I'm joined today by Corry Craighill from Septenary Winery at Seven Oaks Farm. Corry, thanks for being with us and for sharing your experiment. Before we kind of talk about the experiment itself and some of the background information, tell us a little bit about your Chardonnay. What's your goal for this product? What kind of style or characteristics are you hoping to bring out in this product?
Yeah, so we typically are making Chardonnay in barrel. So I try to use as much neutral barrel as possible and working with a turbidity that's like 150. But always trying to balance. I really like to put the Chardonnay through Malo, but I don't want it to be fat or flabby. So trying to work with the acidity, like whether it's the picking decision, I feel like I pick early, but obviously we all add Tartaric when appropriate. So trying to learn more about the balance of malic and tartaric acid.
So the experiments that we'll talk about today were specifically comparing acid additions with tartaric acid versus a blend of tartaric and malic acid. So what is your normal, what's your standard protocol, and why were you interested in testing the other protocol?
So my normal protocol is like just for acidity at least is, well, do you want the whole protocol? I'll just give you the whole protocol.
No, just for acid. So do you normally
Okay.
just add tartaric or do you add more tartaric and malic? We'll talk about the whole protocol in a few minutes. Yeah.
So typically I just work with tartaric. I don't really want my finished pH to be above 3.5. So if I know I'm going to put the wine through Malo, I'm trying to figure out how to not go over 3.5 as the final product.
Okay.
And so yeah, like I said, typically just work with tartaric.
So why were you interested in trying to, what's the rationale for trying to use malic?
To be honest, I wish to learn how it would affect the mouthfeel of the wine. I've always known it's been an option, but I don't know a lot about it as far as my wine, so that's why I wanted to look into it, just to have another alternative.
Yeah. Well, we're glad you did. So thank you for working through that with us. So in order to get an idea of who's in the audience today and what you all are doing, we do have one poll. Rebecca, if you can launch the poll, where we're just going to ask you, how often when you're making your Chardonnay here in Virginia, how often do you need to add acid? So are you never adding acid? Are you always adding acid, somewhere in between? And then when you are adding acid, are you adding tartaric only? Are you adding a blend of tartaric and malic, or are you adding just malic? I'm really interested to see if anybody is doing that. And then if you are adding a mixture, what proportion of that are you adding? So, and maybe make that clear, like how much tartaric versus how much malic. We have a couple people who haven't voted, so we'll wait just another bit here. Okay. Rebecca, do you want to maybe end the poll and then share the results? We'll see if everyone can see them. If not, we might have to. Can you guys, Corry, can you see the results? Yeah. Okay, good. Excellent. So it does look like you're not alone there, that that most of us are adding acid to our Chardonnay a lot of the time. We have a few with a little bit less, but most of the time that's tartaric. We do have some folks with a blend, and then we've got one person with malic acid only, which is super interesting. Rebecca, I can't see the proportions. Is that a short answer that you can see?
Yeah, let me look at the uh
We
there's
only have,
one person who said they start with 50-50 and then adjust.
okay, okay. So I think that's one of the big questions here too, is if you're, if you're adding a blend, what blend do you use? And so we're going to touch on that a little bit today as well. So in order to kind of set things up, I do have a couple of slides to share just in terms of general acid chemistry, and then we'll jump into the experiments themselves. Let's see. There we go. So, much like what we just saw in the poll there, much like what I think Corry's experiences and mine as well, is that most of the time in Virginia, we probably do need, we probably have Chardonnay that comes in with juice chemistry that's where the pH is a little bit higher than we would want it to be for our final target pH. So if we look at all of the Chardonnay that came into WRE experiments between 2014 and 2020, the average pH at juice was about 3.5. And as Corry said, once you all get all the way through fermentation, that's probably gonna climb up a little bit more, and especially if you go through malolactic. So it's not uncommon to need to be acidulating at that point. Just as a point of reference, since we're going to be talking about TA as well, from the same data set, the average TA was about 6.4. So if we think about a good TA for white wines being somewhere between maybe 6 or between maybe 6 and 8, that TA of 6.4 does give some room for acidulation as well, which is good news along the way. When we are going to acidulate, I think it's really, most of us are probably thinking about this as like, we want to make sure that we have enough acid for certain goals, but we want to make sure we don't have too much acid that we sort of affect the sensory characteristics of the wine. So it's good to remember that these have both positive and negative effects on the wine. I kind of think about it like the Goldilocks effect, that there's sort of the too little and there's the too much, and then there's some space right in the middle that's just right. And hopefully, obviously that's a range, but usually our target is somewhere in between there. The biggest issue with having high pH for most of the time, the first thing we think about there is microbial stability. And so when we think about target pHs there, anything above a pH of 3.5 is really thought to kind of put you in a position where you have more potential for microbial spoilage. And in Chardonnay and white wines in particular, you're thinking mostly about lactobacillus and pediococcus. They just tend to be able to tolerate conditions better if the pH is above 3.5. It is possible to have too much acid in terms of microbial operation, at least. When your pH gets below about 2.9, Saccharomyces can get kind of stressed and start to produce acetic acid, not produce as many aromatic compounds, and potentially lead to a stuck or sluggish fermentation. Most of us aren't worrying about that too much unless you're making petit manseng, in which case that can sometimes become a problem. But that's not the only reason that we care about, or that's not the only impact that the pH during fermentation has on the wine. So another impact is that having a lower pH actually helps to extract some of the aromatic compounds that are found in the skin cell and the grape skins. And especially with whites, when we oftentimes don't have a lot of contact time, that lower pH does help us to get a little bit more aromatic out of the skins. Once we get those aromatic compounds, most of the time they're not aromatic when we first get them from the skins. They come in sort of non-aromatic precursors. And it turns out that having a lower pH also helps to release those aromatics from their precursor molecules through the process of acid hydrolysis. So again, you get a little bit more aromatic and you release a little bit more aromatic. You also get to keep a little bit more aromatic. So having a lower pH also helps to slow down some of the oxidation reactions that might lead to less aromatics over time. And it also helps to slow down some of the other things that happen in our white wines through oxidation, like like the production of bitterness and browning. So having that lower pH really does have a fair number of benefits along the way if we can get there. But of course, there's always that balance of we don't want to add too much, and that's primarily because of the sensory impacts of acidity. So as Corry said with Chardonnay, you don't want to have a fat and flabby Chardonnay because that's not really very pleasant. We really want our white wines to have a crisp and refreshing kind of affect to them and have enough acidity to amplify their aromas and flavors. If we over acidulate, though, of course, we've all had those wines where the acidity seems sharp or green or unripe. So of course we want to sort of avoid that. So if we look at the things on the slide here, the things that are in blue are really associated with the pH of the wine, whereas the things in green are kind of more associated with the titratable acidity or the TA of the wine. And it turns out those two are related, but they're not directly analogous. And so I did want to take a quick diversion here since we're going to be talking about pH and TA as we look at all of Corry's data. I wanted to take a quick diversion and kind of clarify those two things, particularly as they have to do with tartaric and malic acid. So when we look at kind of those organic acids that are found in grape juice, the two main players, of course, are tartaric acid and malic acid. There are other acids in there, but the things that are mostly driving the pH and TA are the tartaric and the malic. Once we get to the finished wine, if the wine has undergone malolactic fermentation, then of course lactic acid comes into play as well. When we think about kind of the acidity of these, we can think about that in terms of kind of what the definition of an acid even is. So by definition, an acid is a molecule that when you put it into a water-based solution, it's going to have some hydrogen ions that dissociate from that molecule. So when we look at tartaric acid and malic acid, you can see, well, there's lots of potential hydrogen atoms here that could dissociate, but not all of them do. It's only ones that are in a certain sort of conformation in the molecule. So if we look at tartaric acid, it's only the hydrogen ion that's affiliated with this sort of left-hand portion of the molecule, and then the one that sort of is associated with the right-hand portion of the molecule in a similar conformation. Both of those can dissociate at some point. So we would call tartaric acid a diprotic acid because it can give up two different protons along the way. I will say that they aren't given up at the same rate. So the first one is most likely to be given up. And then the second one, the conditions have to get more and more permissive in order for that second one to get given up. If you look at malic acid, you might say, well, malic acid looks a lot like tartaric acid. It's just missing that one little group on the second bump there. And so very, very quickly, you can predict that, malic acid also has essentially those same two hydrogen ions that it can give up into the solution. So malic acid is also a diprotic acid. When you look at lactic acid basically looks like the right-hand side of malic acid, whereas with that sort of left-hand side chopped off. So when we think about lactic acid only has one hydrogen ion per molecule that it can give off into the liquid to be acidic. So when we think about it from that point of view, which hydrogen ions are able to get given off and when they do, that actually helps us to understand both the pH and the TA of our juice and our wine. In order to kind of show that a little bit more clearly, I'm going to kind of turn this into a cartoon version. So if we think about that, if we look at our cartoon version here, all I've done is taken that sort of mother molecule of tartaric acid and just represented those two hydrogen ions that are dissociatable from that. The same thing for malic acid. It has those two dissociatable hydrogen ions. And then our lactic acid only has one each. Again, this would be sort of in that full acid form, but as soon as you put this into a water-based solution, as we said, some of those hydrogen ions are going to dissociate. So it might look more like this when you actually get it into the water-based solution. So, and you can see here is, again, you can see where if any given blue blob might have one hydrogen ion attached, two hydrogen ions attached, or no hydrogen ions attached. And again, the rate at which they give those up is slightly different between the different sort of base molecules. So if we kind of think about our acid dissociation in this sort of cartoon way, if we were to define what titratable acidity is, that basically represents the total number of hydrogen ions that could dissociate if all of the ones that are represented here did dissociate. So it means if we really force it so that the pH gets really high and it pulls all those hydrogen ions off, how many do we have? So in this case, the titratable acidity doesn't matter if it's currently bound to its parent molecule or not, just matters that it's in there. So if we, in our cartoon form here, I think we'd have what, 13 hydrogen ions that would contribute to the titratable acidity. The reason that the titratable acidity is associated with the sensory component of the wine is that essentially this is what's happening when the juice or the wine gets into your mouth. The saliva in your mouth is a neutral to basic buffered solution, and it pulls those hydrogen ions off of their parent molecule. So what you're actually perceiving is sort of the full amount of hydrogen ions that could dissociate in all of those acids. So that's why we measure the titratable, that's the relationship of titratable acidity to the sensory component of the wine. But of course, we also care about the pH of the wine. So if we think about what the pH is a measure of the total number of already dissociated hydrogen ions. So not all of the total ones that are in there, but the ones that are currently dissociated from the parent molecule. So in this case, I think I counted, we maybe have 7 hydrogen ions that would contribute to the pH of the solution. The pH is not just, it's not just grams per liter like we have for titratable acidity. Instead, this is in this kind of confusing metric of the negative log of the hydrogen ion concentration. So it is a measure of the concentration, but the fact that it's a log means that it's measured in increments of like 10 times as much. So a pH of 3 has 10 times as many hydrogen ions as a pH of 4, which means that there's a big difference between, say, even 0.1 shift in pH. That can actually be a big shift in the hydrogen ion concentration. The fact that it's negative is the reason why the pH, a lower pH has more hydrogen ions, which is confusing, but we just have to live with that part. And it makes sense that the pH is the thing that sort of has the most to do with our microbial or our sort of microbial stability, because it's those free hydrogen ions in the solution that are floating around and interacting with the microbes in our solution. So it's really, I kind of think about it like those hydrogen ions are kind of attacking the cell membranes of those microbes and trying to destabilize the microbes. Well, if they're attached to their parent molecule, they're not really being active doing that. But if they're dissociated, they float around and they have that activity. So in this way, we can kind of, if we think about our pH and our TA that way, we can think, well, if we are comparing then our tartaric and our malic acids, malic acid and tartaric acid, again, are both diprotic acids. So they probably have a similar impact on the titratable acidity of the wine, because both of them have 2 hydrogen ions that could contribute if they were all stripped out. So they have a similar impact on titratable acidity, whereas like lactic acid, because we've chopped off that one side of it, lactic acid has less of an impact on the titratable acidity of the wine because it has fewer dissociatable hydrogen ions to participate. So when the wine goes through malolactic fermentation, we would hypothesize that the titratable acidity would go down because we're going from a diprotic to a monoprotic acid. But then we have to think about the impact of each one of these on pH. So as I said before, the amount of dissociation does depend a little bit on the structure of that parent molecule. And because of that structure, tartaric acid is a little bit more likely to give up its hydrogen ions to solution than the malic acid is. Malic acid is going to hold on to its hydrogen ions a little bit more. And lactic acid is going to hold on to its 1 hydrogen ion even more than that. So if we think about sort of molecule for molecule impact on pH, the tartaric acid is going to move the pH a little bit more because it's more likely to give up its hydrogen ion, and therefore it's more likely to increase that concentration of dissociated ions. Malic acid's kind of in the middle there. It's going to be it's going to push it less than tartaric, but more than lactic. And then lactic acid is going to give us less impact on pH. So again, the impact of malolactic fermentation, we would hypothesize that we would have a higher pH after malolactic because we have fewer hydrogen ions being given up to the solution. So we'll keep an eye on those as we sort of move through the data and see if those hypotheses bear to be true in the data that we saw in Corry's experiment. Now, a couple other things as we're sort of thinking about adding Tartaric versus adding Malic. So why would we add one versus the other? Now, first of all, we only want to add, most of the time, we only want to add things that are naturally found in grapes. Both of these are naturally found in grapes, so they sort of qualify by that particular metric. A lot of times we do add Tartaric over Malic because Tartaric is microbiologically stable. It's not going to go through malolactic, and it's not going to feed lactobacillus or pediococcus or any of the other lacto organisms that might be in there, whereas Malic does. But we also have to remember that tartaric acid is not chemically stable, whereas malic acid is. So especially here in Virginia, where we have high potassium levels in our wines, or in our juices and wines, our tartaric acid is going to interact with potassium in the juice and sometimes precipitate out, particularly as fermentation proceeds. So we might see a shift, for example, in titratable acidity due to that potassium bitartrate precipitation. So, and if you don't take care of it, of course, that can end up to be unstable in the bottle. So it has that problem as well. As we just said, tartaric acid is going to have a stronger impact on your pH molecule for molecule than your malic does. And we just talked about why that was. Just to give you an idea of what that proportion is, one particular paper looked at how much do I have to add of each one of these acids to move the pH by 0.1 pH unit. So in the Sauvignon Blanc that they tested, you needed 0.34 grams per liter of tartaric acid to move that Sauv Blanc by 0.1 pH unit. Whereas if they were adding malic acid, they needed 0.51 grams per liter. Now, the relationship of needing more malic always holds, but the proportion of how much more doesn't always hold. In the same paper they reported for Cabernet Sauvignon, they needed 0.31 to move their Cab Sauv by 0.1, and they needed 0.39 grams per liter of malic to move their Cab Sauv. So again, the malic's going to give you less than the tartaric, but how much less isn't going to be a constant proportion. That just depends on all kinds of other things that are found within the matrix of the wine. Another reason people sometimes think about adding one versus the other has to do with kind of the sensory characteristics of these particular acids. So they are molecules themselves. They may have their own kind of sensory inputs. The literature on this is very inconsistent, inconclusive. There's a little bit of literature that says that if you measure kind of the same amount of tartaric versus malic, which one is more sour? It depends on whether you're measuring that by pH or by TA or by or you're saying the same amount by pH or by TA or by molar concentration. But it does seem that malic acid is perceived as being a little bit more sour than tartaric acid if we've tried to keep those other things consistent. In terms of other sensory characteristics, sometimes malic acid is described as being like a green acid, and tartaric acid is a hard or harsh acid. The sensory papers on that are very inconclusive. At really high concentrations, that might be the case, but at the concentrations that we find in wine, it turns out people usually can't tell the difference between them. So keeping that in mind in terms of sensory. And then the last thing is sort of this idea of I want to replace the acid the way that it would be in the grape. So I want to sort of follow the proportion that the grape would have because it feels like it's more natural. It turns out it's pretty hard to figure out what that actual proportion is. And that's for a couple of reasons. We don't have a lot of data on that. There's one paper from the 1960s that is often cited as like, what is the proportion between tartaric and malic? It's done in California. It included a 2-vine sample, and they had different ratios depending on whether you picked it in August or you picked it in October. But the other thing to remember is that, even if it's not a site-specific thing, every year our acid balance might be different as well. So tartaric acid is going to be relatively consistent. It's going to have a pretty slow decline after veraison. The same vine in the same place year after year might have slight differences in tartaric, but not huge differences. Whereas malic acid, its depletion is going to depend a lot on the environmental conditions. The warmer it is, it's going to deplete much more malic acid. So you may have even noticed in your own Chardonnay or your own grapes that you have sort of high malic years and low malic years based on what that weather is. And it turns out that shifts that proportion all the time. So that sort of reported proportion in the literature between the Chardonnay literature on that particular paper said 1.7 Tartaric to Malic on the early pick and 2.1 when it was late. But I guess I would just say that I think if we looked at that in different regions and in different years, we would get very different numbers. Then the very last thing we need to think about when we think about malic versus tartaric is, of course, the impact of malolactic fermentation. I love this little graphic from Wine Folly where we're looking at our malic acid bacteria sort of consuming malic acid and releasing out the lactic acid. And that is indeed the majority of what's happening during malolactic, but it's not the only thing that's happening. We need to remember that little cartoon, Enococcus is really running a whole lot of metabolic reactions in there that have their own sensory inputs. So we would think the more malic acid we put in there, we might run these other bits of metabolism a little bit more. But I would say that the one thing that we tend to think about the most with malolactic fermentation is the production of diacetyl, or that movie popcorn flavor. And I would say that this is not going to increase if you're adding more malic acid versus more tartaric acid, because the amount of diacetyl that's produced is directly proportional to the citric acid in the solution. So diacetyl is specifically a byproduct of citric acid metabolism. So as long as you're not adding more citric acid, then you don't expect to have more diacetyl along the way. Okay, so as we kind of look through these data, then we want to think about what is the relationship to pH, what's the relationship to TA, and then we'll talk about what your sensory impressions were as well to see if it makes a difference to do malic acid or tartaric acid. Okay, so Corry, we had 2 flights. And she just put her, Corry, I'm going to ask you questions again. Sorry, you were so good at putting your, so we had 2 flights along the way. And basically this was the same experiment run on 2 different lots, but one of them we had 2 treatments and one we had 3. So tell us a little bit about how you set up your experiment.
Am I off mute? Am I off
You
mute?
are off mute. I can hear you.
Off, like how many people I can see. Yeah, the experiment for, I believe both, is I harvest and then chill the fruit down overnight. We do whole cluster press on all of our fruit. I did add a settling enzyme, which typically I try not to add, but I did add it. I don't remember why. And then added some SO2, let it settle, and then racked everything to barrel. I said earlier, I try to target an NTU of like 150 for the experiment. I don't remember what the NTU was off the top of my head, but I know they were all this like within 20 of each other. And yeah, it's everything was a barrel ferment. All the experiment was all in neutral. We had repeats of some of them. That's where Joy will come in, but pretty standard. And then for the rate, Joy, do you want me to go ahead and talk about the rates of stuff? Okay.
Yeah, that'd be great.
So for one of the lots, I'm just gonna pull the sorry, I just want to make sure I'm saying the right thing for the right lot, because my brain doesn't always remember it. So we did 2 different lots. I've got a vineyard site in Goochland, and that's the RC Chardonnay, and then the BV is from Blenheim. Thank you, Kirsty. So on the Rock Castle, we were able to run 3 different wines, or 3 different pieces of the experiment. One was just the control of just tartaric acid, and at 1 gram per liter. The second barrel was the same amount of acid, but split between malic and tartaric, so 0.5 gram and 0.5 gram per liter. And that barrel did go through mallow as well. And then the last barrel was also split between tartaric and malic at equal rates, but did not go through mallow. And then on the Blenheim, I didn't have as much to experiment on, so we did same rate of acid. It was a little bit higher rate at 2 grams per liter. So one barrel got the 2 grams per liter of Tartaric, and one barrel got 1 and 1 gram Malic, 50-50 Malic Tartaric split, and they both went through malolactic fermentation.
Good job. I find myself always having to like check back because we had multiple iterations, but
Yeah,
what this allowed us to do is it gave us two different examples of Tartaric versus Malic, but it also gave us an example of malolactic fermentation versus not malolactic fermentation. And we're going to kind of look at both of those comparisons as we look at the data themselves. And I'll try to be careful to kind of keep telling you which one is which. I think I called the second barrel in the RC was the one for me that didn't have mallow, but
sorry. Yeah.
It doesn't matter. That part doesn't matter. We'll just make sure that everybody knows as we follow through. So as we look at it then to let you guys know what you have in your flights, for flight 1, this is, I'll flip back real quick. So flight 1 was actually this BV Chardonnay. So that's the Blenheim one where there were only 2 treatments. So that was the one where you did have a triangle test. And so you can, and again, this one, both of these went through full malolactic fermentation. The only difference was whether they received 2 grams per liter of tartaric acid, which would be the control, or 1 gram per liter of tartaric and 1 gram per liter of malic acid. And again, all went through full mallow. And then the second one, flight number 2 was that RC Chardonnay where we had 3 different treatments. And so you didn't have a triangle test. We had you taste all 3 of them. And so here again, I will the one that got 100% tartaric acid and went through full malolactic fermentation. That's the control because that's kind of what Corry normally does. Treatment number 1 in my labeling system was it got 50-50 between tartaric and malic, and it did not go through malolactic. And then treatment number 2 got 50-50 of an acid add and did go through full malolactic. So I'll show those to you multiple times. So hopefully you'll be able to always figure out which one is in front of you. So when we look first at the juice chemistry for this, if we look at the RC Chardonnay, so that one came in with a pH of about 3.46. Well, first of all, I should say both of these came in with a pH that was a little bit high. So we're at 3.46, 3.58, both really good candidates for acidulation. The RC Chardonnay came in with a pH of 3.46. When Corry did that acidulation, she was able to sort of get to a target of 3.26, 3.28. And we can see that there's not a big difference in the pH between the tartaric only addition and the addition of 50-50 tartaric malic. And again, that's kind of what we would expect. There's a little bit of a difference, but it's not a huge difference in this case. We can also see that the titratable acidity is pretty much the same for whether you're adding tartaric acid or a blend of tartaric and malic, which is, again, according to what we would expect. The malic acid number here is a little bit confusing. And so this, I think, there's probably multiple things at play here. The first is that we really wouldn't expect there to be more malic acid between the pre-addition and where the tartaric acid got added. So my suspicion is that just represents sometimes, you know, when things are run one day at the lab and they're run a different day at the lab, there's just a small difference. And that difference there isn't enough that we would make a different winemaking decision, but it does sort of show us that there is kind of play no matter who the chemist is, who's running the thing and how good the lab is. There's always going to be a little bit of interplay in those numbers, and that's normal. That's something that we expect for all of our lab tests. The other thing, though, that we might see is that, you know, the treatment 1 and 2, we would expect them to have more malic acid than the control. Here, they do have some more malic acid, but they don't have a lot more malic acid. There is one thing to think about here. It doesn't explain all of it, but one thing to remember when you're adding malic acid in grapes, malic acid in general has a 3-dimensional structure, and it kind of comes in 2 different forms. You can think about it like the right-handed form and the left-handed form. In grapes, it only comes in the left-handed form. And the tests that we use, or at least the enzymatic tests that they run at Imbibe, and most of us would run if you're running enzymatics in the lab, that only detects the left-handed form of the malic acid. So if there's any of that right-handed form in there, it's not going to get detected. And if it's just coming from grapes, you wouldn't have that right-handed form. However, when you're adding it as like an additive from the bag, when they manufacture this, both of those forms are in there. And so once we do kind of that addition, we need to remember that there may be more malic acid in there than what the test is picking up, just because of how that test is working. The other thing I would say here is for the BV Chardonnay, again, that came in with a pH of 3.58, so it did get a higher acid addition. So that one got 2 grams per liter, whereas the RC got 1 gram per liter. We weren't able to get post acidulation numbers on this. That makes a lot of sense though, because this is in the middle of harvest, so it was really hard to get all of these data. So we're really grateful that we were able to get the amount of post acidulation data that we did. So the first thing I wanted to look at was that impact of malolactic fermentation itself. So if we want to look at just the impact of malolactic fermentation, that's looking at the RC Chardonnay treatments 1 and 2. So if we just look at the wine chemistry for those two, so that was your second flight, treatment 1 and treatment 2. If we look at sort of what the wine chemistry looked like there, treatment 1 did not go through malolactic, treatment 2 did go through malolactic, and their juice chemistry was nearly identical. So at the end of all the things, we can see that the pH did go up as a result of malolactic. That's what we would expect. And in this case, it went up by about 0.1. So it wasn't a huge difference, but there was an increase, and an additional increase even over the increase that happened during fermentation. The TA went down, again, what we would expect from what we just talked about. The acetic acid went up as well. And this is something I didn't talk about when I showed you that the metabolic reactions of malolactic fermentation. But acetic acid production is a known byproduct of malolactic fermentation. It's just part of the metabolism of that organism. Some lactic bacteria are going to produce more acetic acid, some are going to produce less. Enococcus is one of the lower producers, so that's part of why we try to select for Enococcus. But there is some acetic acid production that goes along with that. And then the rest of that is just to prove to us that we went through full malo. So if you look back, so here's again what your flights were. I'm going to go ahead and actually stop sharing my screen for a minute and just, I'd like for us to talk just a bit about just the impact of malolactic itself. So we can see the chemistry of it, but most of the time we're undergoing malolactic fermentation because of some kind of sensory characteristics. So if you are able to put your camera on, I would love to have you put on your cameras now so that we can talk just about that piece of the sensory. Okay. Okay, so let's go ahead and where's my questions here? All right, so if we just think about T1 and T2 of the second flight, my first question for you is, did those wines taste different to you? Did they seem different? So on a scale of 1 being they're not different and 5 being they're really different, how different did treatment 1 and treatment 2 of flight 2 taste to you? Very different, or I'm sorry, very different, not different at all. And if you're not able to put your camera on, if you want to write into the chat, you can do that as well. Everybody vote. I can see you. You need to vote. Okay, thank you. I see a couple of 3s. I see a 1, not very different. Tom's got 4. AJ's got 4. Kirsty's at 4. Okay, so for those of you that felt like they were very different, if you're willing, maybe unmute yourself or write into the chat. What was very different for you about those? AJ, you had 4. AJ, what was different for you about it? You're muted.
Too many Zooms today.
Sorry.
It's all good. I got an overwhelming sense of bitterness, especially with the Malic. But and for some reason I tend to be more sensitive personally to Malic. So versus I didn't get that with the Tartaric.
Okay, so for you, the one that
I just got, yeah.
No, yeah, so I'm sorry. So this one was just between it went through malolactic or it didn't go through malolactic.
Okay, I'm sorry.
That's okay. That's okay.
Yeah, I just got a sense of there was definitely some softness on the first one versus there was just this harder edge not on the one that didn't go through Malic.
Okay. Okay. And Kirsty just typed in that the acid seemed the softest on the sample that went through ML. It was much more harsh to me on the non-ML sample. So Tom, you had 4 fingers up as well. Did you have anything to add to that?
They were all very different. In order to not get confused for, well, how would I do this? The 565, I believe, was the control.
Which group were you in?
Pardon me?
Which group were you in?
In group 2.
Okay, so for group 2, at this point, we're just comparing so the 779 did not go through mallow, and the 823 did go through mallow.
Okay, good. Yes. And so 779, much more fruit, vibrant. The acidity is higher. It's very zesty, but it had some phenolics on the back end of the palate.
Okay.
And 823 had carbon dioxide or CO2, zippy fruit, borderline reductive. And so some H2S in there, but a bubblegum palate.
Okay. And that actually, that all kind of makes sense in terms of, we said that when we have more acidity, the astringency might be a little bit more perceptible, which makes sense. If it didn't go through mallow, it's got that lower pH, it's got that higher TA, and it might make any astringency that's in there a little bit more perceptible. And then that fruitiness might sort of be bumped up a little bit with that acid. So that shows us both the sort of what that in-between portion really looked like. So. Okay, anything else? Did anybody pick up any other characteristics for the malolactic itself? I didn't pick up anything that was like buttery or anything like that. That didn't seem, I think sometimes we think that malolactic just makes it buttery or makes it oaky. And in this case, it didn't seem like that to me. But it was really just sort of that shift in the acidity. Okay, so let's go ahead and look then at the difference between the Malic and the Tartaric. So I'm going to share my screen again. Go. Okay, so if we look then at this comparison between whether the acid was added just as Tartaric, or as a blend of Malic and Tartaric, we actually have, again, we can look at that for both of those lots. So for the RC lot, both the RC and the BV lot, we can see that the pH did increase when we were adding malic acid as part of that addition versus just tartaric acid. And again, that makes sense because both of these went through malolactic fermentation, but there was more malolactic fermentation when we added more malic acid. You can also see that that's sort of proportional to how much malic acid, how much of a difference there was between malic and tartaric. The RC lot got a smaller add. So in that case, the differential was smaller, and we see a smaller differential in the pH difference. The BV got a little bit bigger add, and so we see a bigger differential there. In the Blenheim Chardonnay here, that was a 0.1 difference in the final pH between those two, whereas in the RC it was just under a 0.5, so it was a much lower difference between the two. The other thing we can think about is acetic acid. So in this case, again, more malic acid or more malolactic, we would expect to see a little bit more acetic acid production, but lots of other things participate or add to acetic acid as well. So in this case, we did see in both lots having more malic acid to consume did lead to more acetic acid, but in this case, it wasn't proportional. So we just had a little bit more acetic acid accumulation in the RC than we did in the BV, even though we had more malic acid in the BV than the RC. So that just tells us that there's lots of other things that contribute to that as well. I would also say that for all of these, the acetic acid is still well within the bounds of what we would consider to be a pleasant and good wine. It's not sort of getting into concerning levels at this point. So that difference right here may not be a meaningful or a important difference. And then we can look at the difference in TA. So again, we would sort of hypothesize that because of that movement between malic acid and lactic acid, we would have a lower TA in the ones that went through more malolactic. But that's not what we see. And I think this really brings us back to that idea, remembering that tartaric acid is actually not stable either. Malic acid is not microbiologically stable, but tartaric acid is not chemically stable. So as these wines went through fermentation, they did probably have some bitartrate precipitation as the ethanol levels went up. That bitartrate precipitation also decreases the TA, and that the amount of bitartrate is going to be proportional to the amount of tartaric acid. So in this case, which one of those shifts the TA more might have to do with a lot of different complex factors that are sort of beyond, our normal ability to calculate that in the winery. But what we can say here is that both of them are much less a TA than what the juice was. The juice was a TA of over 6, and both of these finished sort of in the below, I guess, 5.2-ish, a little bit above that was our highest one. So both of those lost TA along the way. And it wasn't necessarily that one lost more than the other. These were actually pretty close. But again, the idea here is, was there a sensory difference? So I'm going to show you your numbers again, and then we'll talk about whether there are sensory differences. So again, in the BV Chardonnay, you can see which one was Tartaric and which one was Malic. And then in the RC Chardonnay, this would be a comparison of the control and T2. So hopefully everybody got their numbers there. So again, if you can, we're going to do the same thing here. So if you can put your cameras back on, if possible, so that we can talk about sensory again. I'm going to ask you basically the same question. So maybe if we look first at the at flight number 1, so at the BV Chardonnay, I'm getting them mixed up now. So in flight number 1, how different were the wines to you? So again, if you could either put your camera on and vote with your hands, or put it into the chat. I guess that one was, could you tell the difference between the wines? Because that was a triangle test. So could you tell the difference between the wines in a triangle test? And if you're not able to put your camera on, if you could maybe tell us in the chat. Okay, Kirsty could tell the difference. Tom could. Matthew says he can. There you go. Thanks. Oh, there you go. Yeah, that's a good way to do it. Okay, at Wineworks, with neither of the tasters were able to pick out the one that was different. AJA said yes. So I'm going to come back to you and now ask you, for those of you that were able to tell the difference, what was different? Matthew, you had your thumb up there. Are you willing to unmute yourself and say what was different?
Sure. Does that go back to the question about choosing which one we thought looked different in the questionnaire?
Yes. Yeah. So when you did the sensory before, which one did you think was different?
For me, and I can't remember which one I answered now, but it was just a color comparison. 2 of them had a very similar color, and
Okay.
one was significantly lighter.
Okay.
I'm guessing that was the control, but can't be sure.
Okay. And with color, it's hard to sometimes the color could be any number of things. So yeah. Okay. Other things. Other folks that were able to tell the difference. What else was different between the wines? Kirsty said that the Tartaric gave her a bigger acid intensity. So it felt like it was just more acid intensity. Okay.
I thought the 50/50 was it felt like a little more tired, like less fresh.
Okay. Tired, so that might go along with maybe even if it was a little bit darker. So yeah.
Yeah.
Okay. Tom says softer versus more acidity. So again, it's that perception of the acidity is a little bit, it's maybe altering our perception of the acid. Okay. How about the second one? How about flight 2? Were you able to tell the difference in flight 2 between I guess the question is how different was the control from the T2? Did you feel like the control was different from T2? This one had a bigger difference in the ad. So we were talking about that's a 2 gram per liter ad instead of a 1 gram per liter ad. So maybe we can do the same thing on a scale of 1 to 5. How different was the control from T2? Again, if you can write it into the chat, if you're not able to put your camera on, that'd be great. Okay, so Steve's got 2, so not super different. Kirsty's at a 2. Oh, I don't know why I have balloons coming up. Zoom is such a sometimes it's such a mystery to me too. How about you, Corey? How different did this one seem when you tasted it blind? About a 3, yeah. Okay. 2. Yeah, so for whatever reason, this one didn't seem to have as big of a difference for us. And we'll get the sensory numbers as we kind of once we do the statistics, we'll know for sure when we what that looked like. But so I guess my question now as we sort of go back is, you know, what do you think about adding malic acid? Is it something that you would want to do? Is it something that you think it might be worth it? How are you feeling about it, Corey?
I mean, I feel like I mean, of course I'll run the experiment, would be glad to run the experiment again. I feel like Tartaric, I'd be curious of like the price. I don't know if there's a big price difference, even though I know I purchased them.
I actually did look recently because I was talking to Rebecca about because they used to do this at Cunningham some too. And so I actually looked up the numbers, and I think the price probably changes over time. But when I looked at the Carolina Wine Supply site yesterday for this, it looked actually like Tartaric was less expensive than Malic. But I think in the past it's been the other way around. So it might be like just depending on the year as to
Yeah.
what the pricing is.
I feel like the Tartaric is a little more fresh. I mean, and having to like the logistics of like I mean, this is all WRE experiments, but like the logistics of keeping track of Malic versus Tartaric, it's easier just to add Tartaric. It's one less thing in my cellar. If they're both naturally occurring in the grape, then you know, I'd rather if it's not making a big enough difference in the wine, I feel like mallow versus no mallow is making is making a much bigger difference, especially when you think about, you know, I have to wait a really long time to add my SO2. I'm having, you know, this year I had to inoculate. You know, I think there are bigger differences that affect the pH and how the wine feels and tastes than Malic versus Tartaric.
Yeah.
So I'd be glad to run this experiment again, but it's easier not to.
Well, and I think like you don't necessarily have to, right? Like the idea is that, you know, is this a substantive difference that you feel works toward your winemaking goal? Or if it doesn't seem like it's that different, then sometimes, yeah, the better answer is, you know, do the thing that makes that fits with the regular protocol the most, that's least likely to have, you know, least likely to have an error along the way. So, so time said that, you know, late or later Malic additions may give us more control to dial in what's best for the palate. So yeah, for things particularly like if you don't if you don't mind having residual Malic at the end, for sure. So yeah, I think if you're expecting to leave Malic at the end, then that is another way of kind of, again, later acid additions are easier in either sense to do that. But yeah, this way you could do a bench trial of either one and see which one you like the palate better for sure.
I'd be curious, did this change anyone else? Like, is anyone gonna buy Malic this year? Especially
Well,
based on the beginning poll, like most people are using Tartaric. Did
yeah.
this change anyone's mind?
Right. So Kirsty says she doesn't think she will experiment with malic acid addition. She prefers the freshness and more sharp acid of the Tartaric. But she's very happy that Corry did this experiment for us to taste. So thank you for making that happen. But yeah, I mean, I think that is like, and it might be part of that wine, that piece too, that like, because we're having to add acid, we're lacking freshness. And if we feel like the Tartaric is giving us more consistent, lasting freshness, then maybe that's what's achieving that goal in the wines that, in the grapes that we're seeing, you know, and that might be specific. I mean, it might be a different answer for different vineyard sites. But it might be that like, yeah, if the goal of adding acid is really that sensory freshness, then maybe the Tartaric is going to give you that more consistently. So
Yeah, especially if I don't know what other winemakers here are doing, but I really like the like broadness and the texture that mallow can bring. So but I don't want to lose freshness. So
yeah. So AJ says she did a similar in-house experiment with both this year and decided to continue with Tartaric for the same reasons. So it seems like I mean, I think it's a relatively straightforward experiment to run in your own winery. You just need 2 different barrels that are the same. And it is kind of worthwhile to test that out if you're curious about it. But that doesn't mean you have to, I mean, part of doing the experiment is to prove to yourself that you want to, you know, yes and no are both important answers, I guess is what I'm saying. So I always think that's true, but
yeah, definitely.
any other comments about mallow versus no mallow, or Tartaric versus Malic in our white wine editions? Anything else in terms of sensory impressions or logistics or insights from the group? Before we go today, I will have Rebecca drop the registration link for next Tuesday's session if you're interested in coming to Blue Valley. Again, this is kind of a similar idea in terms of thinking about how do we make those acid additions for our red wines so that we can get to a good microbial stability without over acidulating. We'll be looking at kind of early versus late, so it doesn't matter when you do it. We'll even have like, doesn't matter why you do it kind of situation. And so we hope that you can make it to that as well. Thank you so much, Corry, for doing the experiment and for sharing your insights with us and keeping track of all of these things and getting us juice samples. I know it's a lot to do, especially during harvest, so we really appreciate that. We also want to make sure, again, to thank the Virginia Wine Board for their continued funding of the research exchange. We did, at the wine board meeting last week, we did get funded again for another year. And so we're delighted to be able to continue to offer these services. And again, keep an eye out on your email box for that survey coming out in June, just so that we can have some good feedback from you about what you would like for us to keep doing. So thanks to each one of you for doing your sensory sheets and for being at the call today. If you do have any additional questions or comments or whatever, I'll stick around for a little bit afterwards. But thanks so much for being here, and hopefully we'll see you next time.